first two were the product and the quotient. And remember that the difference there is that product is when you're multiplying, quotient is when you're dividing. So if I look at this top property right here, if you have a plus in the middle, then to put the logs back together, you need to multiply the argument, which is like this thing and this thing. So you'd combine them into one log, so it'd be log little b. And then in the parentheses, if x and y were added as logs, they'll be multiplied in the parentheses when you're combining them back together. Okay, then same thing on that second rule. If I have a minus in the middle, okay, a minus when you put them back together is going to be division. So it would be log little b of x over y. And then one thing just to think about, it does matter which one comes first because that's the one that's going to end up on the top. So if x comes first minus y, x has to go on top, y on bottom. Okay, then also remember here, okay, we didn't have to worry about this yesterday, but you can only combine logs that have the same base. So for example, if it's a base 3 and a base 5, you can't put those together. They have to have the same base. Okay? Huh? With the same base, yes, thank you. I was wondering why that blank was so big. Okay, they have to have the same base. So, look at number 1. Okay, we're adding in the middle, then what do we do with the arguments? Multiply. So I'd have log little 3, and then I'd take 8 and 5, and I'd multiply them together. 8 times 5 gives me 40, and then you'd be done. Okay, so you're just putting them back together today, and then tomorrow we'll do this with solving. Okay, look at number 2. I have a plus in the middle. That means that I need to multiply the arguments. So I'd be doing 2x times 3x. Okay? Yep. So you'd have, look, log 5, and then it'd be 2x times 3x. Okay, which as he just said, you'd multiply the numbers in the front, get 6, x times x counts as x squared. Should be 6x squared. Now, if you don't need to show this middle step, I don't care about that. That's totally fine. Okay? All right, look at the next one. I have a log base 3 of 6x plus a log base 12 of 4. So do I multiply, divide, or neither? It's neither. Why? They don't have the same base. So then you would just say, cannot combine. Okay, and then again, remember that when I say the base, I'm talking about this number right here. So if one's a base 3, one's a base 12, you got to leave them separate. They can't go together anyway. Okay? All right, next row. We are minusing on this row. So first one, I have log base 3 of 18 minus log base 3 of 12. Then that's log base 3 of 18 divided by 2. And what is 18 divided by 2? Log base 3 of 9. Good. Okay. Take a look at number 5. Next one. Okay, they're both log base 3s. We can go ahead and check that first. And then if it's a minus in the middle, I know I'm going to be setting it up as a fraction. Remember, it'd be the first one, which is a 20x, divided by the second one, which is a 5. And again, if you can do that in your head, cool, no problem if you want to skip writing this step. Okay, what is 20x divided by 5? 4x. Good job. Okay, take a look at number 6. Okay, this time I have both log base 3s, but on top I'm going to have 8x to the 7 and then 2x to the 3. Now, you covered this back in Algebra 1. You covered it again in geometry. We haven't really talked about it a ton. But when you're dividing expressions with x, the coefficients you divide as normal. So like 8 divided by 2 is going to give us what? 4. But then what do you do with the x's if they're divided? You subtract. Good. So if I have x to the 7 divided by x to the 3, that's going to cross 3 of the x's out. How many will stay? Good. So it'll be log base 3 of 4x. 4. Okay, and then I'll put a little note here. You need to subtract exponents when dividing. Okay? And probably most of y'all remember that, but just in case. Alright, so let's get down to 7 and 8. Now notice that 7 and 8 all have 3 logs. So you can put them all together in one step, or you can break it up into steps. It's really up to you. Number 7, what am I going to do with the 4x and the 5y? Let's just put these two together first. Multiply, correct, because what's in the middle? A plus. So log base 3 of, and then what is 4x times 5y? 20xy. Very good. Okay, so I put those two together. I get 20xy, but I still have a minus log 3 of z. Okay, well then in my next step, I'm going to put those two together. What will I do with 20xy and log z if they're minused? Yep, that's right. So it'd be log little 3, 20xy on top, z on bottom. So the two that are added or multiplied, they're going to stick together on the top, and then the one that you're minusing is going to end up on the bottom because you're dividing it. Now, take a look at number 8. You still have to follow PEMDAS when you're doing these. So when I see...
Pardon this interruption. You just received an email from the photography field trip today. Please take a look at that list and put those students down to the front entry that's near Grand Central so that they can depart once again for the photography field trip. Take a look at the list of students. Please send those students immediately to depart. Thank you.
Okay, so you still have to follow PEMDAS even when you're doing these rules. So these parentheses around this part mean that I have to do this first. Otherwise, you would just kind of go left to right. So if I start with this part, I'm going to keep log base 3 of 15x the same. But I'm going to combine the two in those parentheses. So if it's a log base 3 of 10 plus a log base 3 of z, that would be what? Log base 3 of 10z. Good job, that was right. And then now that I have those two pieces and I'm subtracting, I can turn it into a fraction by dividing. So it'd be log little 3, 15x over 10z. And then for today, you can leave it like that, but if this ever comes up on SAT or ACT or anything like that, they wouldn't leave 15 and 10, okay, as a fraction because you can reduce it. So 15 and 10 both divide by what? 5. So then the top 15 divided by 5 would be, yes. So it'd be a 3x on top and a 2z on bottom. Okay, but for your homework, I'm fine with this. You just need to know that they're going to expect you to reduce those if it comes up on one of those tests. Got it? Okay, there's one other rule. So flip over to the back. Okay, we learned one other rule yesterday. We learned the exponent rule. Okay? So remember that the exponent rule, I think we actually called it the coefficient property yesterday, but it's the same. Okay, if you have an n here in the front, you remember you're allowed to move that up to be an exponent. So it would be log little b of x up to the n. So just like yesterday we were moving that exponent down, today while we're simplifying, we're going to bring it back up. Okay? So take a look at number 9 for me. Where's the coefficient? What number is it? It's right here. It's the 8, right? And so I'm going to take that and I'm going to pull it up onto the x. So what I'm going to have now is log little 3 of 3 plus log little 3 of x to the 8. So my 8 jumps up and now it's an exponent on the base x. And then from there, if I'm adding in the middle, what can I do there? To combine them into a single log multiply. Very good. So 3 times x to the 8 is just 3x to the 8. Okay? Take a look at number 10 right next to it. Okay, what number are we moving? The 4, cross it out, and it's going to be applied as an exponent on the base y. And then you'll multiply. So it'll be log little 5 And then what's going to go on top? Oh, wait, hold on. We're multiplying. So it'd just be 10y4. Good? Okay. All right. Take a look at number 11. Next one. Okay, so first thing that you would do is move the exponent. So what numbers are going to be my exponents? Okay, cross out the 7, put it up top. Cross out the 2, put it up top. Okay, from here, you're just going to combine the first two terms, and then we'll combine the second one after. So these two are added. Are we multiplying or dividing the arguments? Okay, good. So it'd be log little 6. And then 2 times x to the 7 is 2x to the 7. Okay, then from there, my logs are now subtracted. So what am I going to do with those two sets? Divide. Very good. So it'll be log little 6. My 2x7 gets to go on top. And then my 3 squared goes on bottom. Now, 3 squared, since it's a number, what is 3 squared the same as? That's really a 9. And so you could leave it as 3 squared if you want to. But might as well reduce it. Okay, take a look at number 12. Okay, now this is where it gets tricky because you really have to think about your PEMDAS. So the first thing that I would want to do if I have parentheses here is combine these two logs in the middle that are added. Okay, so if I'm combining those two in the middle that are added, how would I do that? Multiplication or division? Okay, good. So I have log little 6 of 10 minus 5 is on the outside, not on the inside. And then if I have log of 6 and log of x, that would now be the log of 2x. So step 1, I combine the added logs. Step 2, I have to move this up. And so if my 5 is here, it needs to be applied onto the 2 and the x. So when I cross it out and move it, I need to make sure it goes on the outside. So the 2 and the x are inside that power of 5. Then from there, I can use the subtraction property where I divide them as a quotient. So it would be log little 6 of 10 on top, 2x to the 5 on bottom. And then remember that you do need to have these parentheses here because they show that the 5 applies to both the 2 and also to the x, and you need that. Okay? Alright, take a look at number 13. Find your parentheses that we need to do first. Which two do we need to combine first? The 3, the x, or the y? The 3 and the x, because they're in parentheses together. That means that those guys have to go together first. They are added in the middle. That means we're doing what with the arguments? Multiplying. Very good. So it'll be log little 2 of 3 times x is 3x. Then from there, minus log 2 y. Okay, so I combine my parentheses. Next, I need to move my exponent. So if I have a coefficient here in the front of 2, I can move that up to be a squared. And remember that this squared applies to both the 3 and to the x because they were both inside already. So now I have log little 2 of 3x squared minus log base 2 of y. My last step, now that I have subtraction in the middle, is to divide. Very good. So it'll be log little 2 of 3x squared over y. And then if you want to, really you should put an extra parentheses around all of that just to show that all of it's in the log. But if you don't put it, I won't take off, but just know you probably should. Okay? Alright, number 14. Okay, give that one a shot. Find what you need to do first. Huh? 13? 14? Okay, so what, this one is harder because not only do you have multiple logs, but you have parentheses too. So what do you guess we should do first? The parentheses. Okay, good. So I'm going to mainly just focus on the parentheses right now. Should my first step be to multiply these? No, that's correct. This is why. Look at this very carefully. Okay, you actually have an exponent in there that has to be moved first. You're not allowed to multiply logs when you have exponents that have to be moved, unless they're on the outside, which is like all the other examples. So the first thing I'm going to do is I'm going to cross this 3 out, and I'm going to put it on the V. Now I can combine those two. So if it's addition here in the middle, that means that I need to do what with the 2 and the V cubed? Multiply or divide? Okay, good, multiply. So I have log base 3 of 14 plus 7 log base 3 of u, and then minus log base 3 of 2v cubed. So remember, that's your order there. You have to move that exponent up first, because it's not on the outside of the parentheses, it's in there with everything else. So you move the exponent, multiply them together. Okay, next step. Now from here, I'm just going to go left to right. So these two are added. That means I'm doing what? Multiplying. So I'll have log little 3, put these two together first. So it would be log little 3 of 14u. Oh yeah, we do need to move the 7. Sorry, I didn't see that. Thank you. So then where's the 7 going to end up? On the u. Good. So put it right there. So I'm going to put a little arrow here and move my 7 to right there. And then from there, if we're subtracting, then we need to do what? Divide. So you'll have log little 3 of 14u to the 7 over 2v to the 3. And since none of my coefficients were outside parentheses, that's why I don't end up having any parentheses here in my log when I'm grouping stuff. Okay? Then from there, 14 divided by 2 gives me what in the front? Good. So it'd be 7u7v3. Make sense? Okay, there is one other thing that is on your homework that is not on your notes. So I want you to go to your homework and flip it over to the back. I'm going to just give you a couple more. The main thing that is missing from yesterday to today, okay, look at numbers 11 and 12 on your homework. You remember the fractions in the front? Where did those come from yesterday? Do you remember? Huh?
Square roots.
Yeah, the roots. So remember that a b under a square root is a 1/2 power, and a b to the 1/3. This is just the back of my homework sheet, since it only has a front. Is b to the 1/3. So when you're converting these backwards, that's what those fractions will end up turning into. So for example, yes. Okay, which one? Uh-huh. Oh, thank you. Put an x3 on that. Thank you. Okay, so we're going to do 2 examples on the back. Okay, just to give you examples to look at for those 2 things. Okay? So number 4, write in your x cubed. And then flip back over to the back. Okay, so let's say that you had this 1/2 log of 6x plus log of 2x parentheses. Okay, so in the middle of the parentheses, I see that my logs are added together. Okay, if my logs are added together, that means I'm doing what with my arguments? Multiplying them. So if I do 6x times 2x, what do I get in there? 12x squared, good. Okay, then from there, my 1/2, since it's in the front, it's going to move up as an exponent to be right here, which means that now I have log of 12x squared to the 1/2. Okay, but then remember, what is a 1/2 power the same as? A square root. So that would really be log base, actually the base was never listed, and then square root. So yesterday we practiced expanding those. You should also be able to simplify those. Okay? All right, let's do one cubic root example just to make sure that you have one of each. Okay, so this one is going to be 1/3 log 2 plus log x minus log y. Okay, so first question, there aren't any parentheses on here. Then what does the 1/3 apply to? Does it apply to multiple logs or just the log 2? Only the log 2. Notice that here, these guys were grouped. That's why they shared the 1/2. Okay, but this 1/3 only applies to the 2. So I'm going to move it up here on the top to be a log of 2 to the 3rd plus log of x minus log of y. Then from there, I'm going to convert my log of 2 to the 1/3 to be a log of cubic root of 2. So remember that any time that you have something to the 1/3, that's going to switch back to be a root. And then from there, now I'm going to put all my guys together. So let's just do this one in one step and see if everybody's good with that. So these two are added, which means that I'm going to do what? Okay, so it'd be cubic root 2x, and then what about minus y? Where is that going to end up, top or bottom? Bottom, because it's divided. Now, quick question, should the x be under the square root with the 2, or should it be in the back, separate? It should be separate, good. Okay, also you'll notice that I didn't put a base on either one of those. What's the base if it's not listed? 10, good. Okay. Alright, so flip over the front. I'm going to give you a couple of these to try, just to make sure that we're getting them right, and then you'll have some time to work. So why don't we do number, this one, 10 and 12. 5, 6, 10, 12. Okay. What do you mean a 1 over? So you have to go in order now. So you actually have to move this 4 up first, then multiply these together, and then put the 3 on the outside. That makes sense? That would turn into log of. Yep. And then the notes, I did set that up in my mind. There's a video of them on the YouTube. Okay, let's just check number 5. Most of y'all seem to be getting it, which is great. The first thing that you should have done is moved this 4. And then the second thing that you should have done is these parentheses. Okay, so if I have log of 2 plus log of x to the 4, that's going to be log of 2x to the 4. And then if I have that 3 in the front, then that 3 is going to move up to go right here. So be careful about, you shouldn't have extra parentheses around the 2x. X to the 4 should be the only part that has the 4. So your final answer would be this, log little 3, 2x4 up to the 3. Okay, let's go right next to it. What are we doing first on number 6? Okay, the parentheses, good. And we need to move the 3. Good. So my 3 moves up, then I'm going to multiply. So I'd have log 2 minus log of, and then if it's 4 times x cubed, that's just 4x cubed. And then when I create my fraction, these guys have to stick together, but they're just going to end up where? On the bottom in the fraction. So it'll be log of 2 over 4x cubed. Okay?
Can that be simplified to 1/2?
Oh yeah, you could reduce that. That'd be perfect. So 1 over 2x cubed. Okay, but if you can get it to here, I'm fine with that. But for standard tests and stuff like that, they're going to reduce that. Okay, number 10. Okay, a lot going on number 10. What needs to happen first? Okay, parentheses. And I'm going to go ahead and move this 2 at the same time and make that an x squared. Then my parentheses here. In the parentheses I'm adding, that means I'm going to do what with 5 and x? Multiply. So I have log 3 of 15 plus log 3 of x squared minus log 3 of 5x. Because I'm multiplying 5 and x together in the parentheses. Actually, yeah. Okay, then from there, I'm going to combine these two first. These two are added. That means I'm doing what with the arguments? Okay, so log little 3 of 15x squared. And then if I have a minus next, where's that going to end up? On the, yep, on the bottom. Okay. And then look at your numbers. We can divide those, and the x's we're going to subtract. So you'd have log little 3. 15 divided by 5 is a 3 in the front, and then x squared divided by x leaves 1x left over. Okay? Alright, I'll give you another minute or so. Samuel, I don't think got to 12. So give that one a shot, and then we'll check it. Which? Yeah, sure. You should have. Yep. Well, that one you need to combine. So, like, you should always be done with one block. So, if you still have two of those, yeah. I do.
What?
There you go. I stopped when I got to that one. I'll check the other ones in a second. Okay, so look at number 13, or number 12. Okay, first thing I'm going to do is move this 5 up. So now it's a y to the 5. And then the next thing that I have to do are these parentheses. But in the parentheses is a minus. That means I'm dividing. So my 1/3 stays in the front, log little 3. And then 7 is going to go over y to the 5. because it was a division in there. So that's a fraction now on the inside. And then when I move my 1/3 up, that's going to turn it into what kind of root? Cubic root. Good job. So you'd put the little 3 in the elbow, that's your index, and then you'd have 7 over y5. And that'd be your answer. Make sense? Okay, you have a little less than 20 minutes. You do not have a quiz tomorrow, but we are going to use this to solve. So if you've missed a day of notes, I'd make sure to get caught up on those before tomorrow. Okay, then also homework grades have been entered. Your quizzes from before spring break has been entered. So if you haven't checked Focus in a while, then do it. Okay? Yes, they all right. Good job, my friend. Good. What I like to hear. Good job, Safa. Good job, Brittany. Anybody else have yesterday's homework to turn in? A Manchu stick? Ashton had a sleepover with his brother like the first day of spring break, and then the brother went home and his dad called me. He's like, Ethan tested positive for the flu. And I'm like, God, are you kidding me? But we never got sick. So